Hello my friend, my name is Anton from gNMI.com and today we continue our demo series of pygnmi, the Python library created by us for you to help you manage your network elements over the gNMI interface with Python. The second demo would be dedicated to the second operation out of the gNMI specification, which is called get. Get allows you to collect the live information such as counters or configuration from the network element upon the provided gNMI pass. In the previous video, in the first demo, just to recap, we have covered the first type of the operation, which is called capabilities, which allows you to get information about the supported YAN models and gNMI version and other useful elements. So just to remind you the topology, we have our gNMI server, which has both IPv4 and IPv6 interface, as pygnmi supports communication towards the network elements using both IPv4 and IPv6, and two network element, Arista switch and Nokia router, which have gNMI clients enabled, or more precisely, gNMI server enabled on their side, and we will continue working with them upon collecting the information. Let's switch to our gNMI code that we are using. To get the details about where we are right now, I suggest you to watch the previous video. We will create a new file right now. Actually, we'll create the two one. The first one would be called inventory, and in this file, we would store the information about our host. And the first videos, we have created two separate variables. However, in some requests or comments we have got from you, we would advise, okay, this is by far not the most optimum way, and there is a better way of doing things. Obviously there are, and as we promised this demo series, we will familiarize you with various setups and code snippets which you could use in order to manage your network elements. So the first modification, what we will do, we will take just our variables, which contains, as you might see, IP address in IPv4 or IPv6 format, the port where the gNMI is running, and credentials, username and password to connect to the network element, and we will put them into a separate file. Let's call it inventory. Here we would create a list where these two elements would be just an elements of this list. We could still retain here all our comments telling for ourselves that this is credentials and in general connectivity details to get to the Arista router. We also take the same stuff for the Nokia, and it slightly modified. And finally, we have the very nice and clean inventory file. We have here a single variable called hosts, and this is a list containing two containers or two dictionaries, and each dictionary has the same set of their information, such as, again, IP address, port, username, password. All these details we need to have in order to connect towards our destination network element. Now we will create a new file. Let's call it get.py. So get.py means that this is the file where we would compose our code to manage network element using their gNMI. So we just provide the standard path to the Python user bin environment. Python. In previous models we was explaining, in previous demo we was explaining how to install pygnmi. So if you have questions how to do it, either watch the first video or just disclaimer, just run in your CLI pap install pygnmi, and it will download and install for you the latest version. So we need one class out of this model. That's why in our code we imported from pygnmi client. We are importing the gNMI client, which is proper interface, how to interact with your network elements over the gNMI, and that will gives you the very easy, in very easy format, the response data. So we would also import the variables from our network, about our network elements, from the created inventory file. So this is our inventory file, and our variable is called host. So that's why in our main script we are importing from the inventory file, we are importing host. So this would remove necessity to store the variables directly in this file. Now we could start creating our main body. So body, and in the body we will now create the script that will allow us to connect to the network element. So as we have now the list with the same data, we could create very easy for loop, and this loop will allow us to establish the connectivity and one by one pull the data. The gNMI is working very fast, and in this scenario, having it in the loop, not in the parallel scenario, is quite okay. We will cover the parallelization and all the stuff later in our demo series showing the integration with gNMI, or just working directly with the threading, how you could even more speed up the code. So at this stage, as said, it's going in the parallel, and using the same approach we have explained in the previous session, we are building the channel towards our destination network elements using the gNMI client. We need to provide a number of the parameters. So you see the target, which is tuple. So the first parameters here would be then the tuple containing their first IP address and then port. So we provide out of our list IP address and port. Afterwards, after we have provided the target, we need also to provide their username, which is coming from the same inventory file. Username. So we also would add the password, which is going again from the same file. And finally, as we are using the insecure channel, as in our lab, we are using the information that their connectivity is insecure, so don't rely on the certificates. We open this channel, and now we could work with the connectivity. To get the call, the get call, the get operations by explaining, we could do it very easily. So we would collect the result, which would be a Python dictionary, so native Python information, which you don't need to parse further. We collect it using the gc get. To get per the gNMI specification, we need to provide certain parameters, such as, first of all, the path, so what exactly information we are pulling from, and type of the information. By default, we are collecting all, but we could specify, we could collect only the config or state or operational data. So, but the first is path. So the path is not default. The data type has some default value, so we could skip providing it. The path within the gNMI structure is quite a complicated structure. That's why when we were creating the PY gNMI library, we were thinking about the simplification to you, to us, because we're using it ourselves. And we need to pass towards our model just in a normal string format, the list of the strings containing the path with to the resources that we are going to collect. So let's create the list. As said, is just a normal list with the strings internally. Within the strings, we define per the normal Young specification the path. So how we do it, for instance, we would like to collect information in the open config models, open config interfaces. So we would like to collect information about all the interfaces, and we also would like to collect all the routing information collected to the on the network element using the open config network instances. So if you are familiar with um, netconf, you would understand that this is the name of the model. This is top level container. If you're familiar with the RESTconf, again, same stuff. This is the model of the Yank model, the name of the Yank model, and this is top level container. If you're not familiar, just come to our network automation training. We explain you everything about the Yank. In the simplistic scenario, we could provide just the top level container prepended by the name of the model. We could go further. We could specify the certain interface or even certain field out of the interface. There is the amount of the nesting is not limited. So let's collect at the topmost level all the information that we would like to see. So all the information about the interfaces and network instances that the devices have. So as said, we need to pass this parameter. So that's why to our get call, we would provide to the pass parameter the value of this list. So you don't need to think how to convert it into the protobuf, which gNMI requires. Our PY gNMI tool will do it for you. And finally, we could just print the result to see what we are collecting. So we create a simple formatted string. We will use the IP address to identify which device we are collecting the information from, and actually the result itself, so that you would see how the data is represented. So, and after that, we'll add some just empty string to ease the visualization. Now let's execute this script. So Python get. So you see the information is already collected just when you press the button. Let's take a look what we have here. So see quite a lot of the information. The first, you see the IPv6 address, which in our demo is related to the Arista. So .a at the end, you would see that .a, this is the Arista. So we have collected, we have passed two passes which we would like to collect the information from. The data is Python dictionary, so you could directly call any information you would like. And it would contain the information about the interfaces, and in the open config models, I mean, Arista provides back the models that you are using. It provides all the data, including the configuration part, as you might see here, as well as the counters, like state parts, which contain the information. The reason why we see everything, because we haven't specified which exactly data set we would like to collect. And by default, our PyGNMI model collects everything, both configurational and operational data. So as we have provided two passes, somewhere just further down in this pass, we would see that we have the routing part. So just bear with me. We have somewhere here, you could see the directly connected routes, the other information. So we are start at this stage collecting the information about the open config model. So as it is provided, network instance model, as it is provided in the one dictionary format, it could be a little bit difficult to figure out, but you can start working directly with it rather than relying on the parsing. So actually it starts here. So we have a timestamp, and then we have pass again the name of our module and all fuzzy variables. The same information is collected from the device having IP addresses .11 in the end, which is Nokia router. And you could see here the amount of information by visual thing is significantly less. However, in reality, the information is the same. So we have the interfaces and all the information related to our interface. And we also have the network instance. So layer 3 information contain the information. So the reason why there is less information, just because by the way how the Nokia the way how the Nokia are handling the open config models, because we have used open config models. If we would collect the information using the different models, for instance, the Nokia native pygnmi is Yannick model agnostic, you could provide any path, the proper information would be collected. So as you could see, you could start further parsing this information as much as you need without conversion into the JSON or out of JSON or YAML or protobuf in other format. This is directly available for you. You could even start sending this information to your monitoring system, to Prometheus or to the InfluxDB, and this information would be stored and processed. Or if you build the real-time analytics, again, this is very good to rely on the gNMI for collection of the information. Thank you very much for your attention today. Stay tuned. Today we have covered the get gNMI operation. In the next hour video, we will cover the set operation. Take care and goodbye.